Number 29, we have a winch being pulled. I believe a winch pulling, sorry, um, is pulling what, a pole? Yeah, a pipe. So this is your pipe. Drew that in green. The winch is up on the building. The building is 12 meters high. The pipe is 12 meters long. The winch is pulling the pipe towards the top of the building to stand it upright. The rate at which it is pulling it in is that distance will get smaller. That's why it's a negative rate. It's 0.2 meters per second. So as I picture this thing in motion, what do we have changing? Well, the pipe is 12 meters. It's not changing. The height of the building is 12 meters. That's not changing. This I'll call it C for right now. That is changing. Okay, so they want to know the rate of vertical change and the rate of horizontal change. So they put it on a grid for us. So the point here, the end of the pole, has coordinates x, y. So as the thing gets pulled to the top of the building, the x coordinate, right, that's to get to the point, I go over x and up y, right? That x distance will be getting shorter as this thing goes upright, and the y will be getting larger. So my dx dt should work out to become a negative, and my rate of change for the y should turn out to be a positive. So the trick here is that we're going to have to draw in and separate it into two right triangles. This distance is also x because that's the distance I would go over as the pipe gets pulled up. That's the distance I would go over, so that's also x. This distance here would be y. So I'm going to redraw this and stop it actually at the point where they say they want it stopped. They want it when the y is 6. So let's see if this works. I had it. I need to paste. Not sure how to do that. Sorry for the delay. I did copy. Maybe the scissors. Yeah, there it is. Okay, so the pipe is going to be stopped at 6, and it's 12 meters long. The y is 6. Okay, I don't know exactly where it ends up on the x-axis, but I do know that the y is 6. I know that that's 12. I know the top of the building is at 12. So this rope is pulling it that way. That we were calling a C. This distance we're calling x. This distance we're calling y. This one we're going to call 12 minus y. Because if this whole distance is 12 and the bottom part is y, then that part must be 12 minus y. This one's interesting. It's a system of equations. So in motion, those are the things that are constant and also the things that are variable. I've got two right triangles here. So I can write Pythagorean theorem, the lengths of the sides of one of them, the bottom triangle, to be this. Then I've got the length, oops, I like this one better, the lengths of the sides of the other, move that over a little bit, to be x, this is the top triangle here, x squared plus 12 minus y squared equals c squared. Okay, so when we stop it at 6, that'll help us get our y's, our x's and y's. But first, actually, we have to take the derivative of each of these before we can freeze it in time and start plugging in our x's and our y's. So the derivative of the top one is 2x dx dt plus, this is chain rule, 2 comes down, recopy the base, reduce the power by 1, times the derivative of 12 minus y, so that's just a negative 1. I'm going to have to move that over more. Oh, I need the scissors. Didn't want to take the y with me. Try that again. There we go. Gonna move that over a little bit. dy dt equals 2c dc dt. Okay, we know dc dt. They told us that. That's the rate at which it's pulling the rope, -2. Sorry, -0.2. C we don't know yet. dy dt and dx dt are both unknowns. That's what they wanted. They wanted to find the horizontal rate of change and the vertical rate of change. So this one's going to be challenging. How the heck can we find two missing rates? Well, we're going to have to use this other equation over here, and we've got to take the derivative of that thing and solve the system of related rates. So I'm doing two related rates equations because I've got two unknown related rates. So now that I've got my two equations, equation 1 and equation 2, I've got to somehow solve these. Now I can find my x's and my y's also. So I know that's 12. I know that's 6 because it said stop it when y is 6. So then I also know 12 minus y up here is 6. I know that x, well, I don't know what it is yet, and I don't know what c is yet, but I can do Pythagorean theorem twice to get to c. First, I want to find x using this bottom right triangle. I've got 6 squared plus x squared equals 12 squared. So I got 36 plus x squared equals 144. X squared equals 1. Nice. Let me just get the calculator out here. (144) minus 36 is 108. Then I need to square root that. And I get 10.4 approximately. All right, that's my x. Now to find my c, I know that that's 10.4, so now I'm going to do the top right triangle Pythagorean theorem. I know x is 10.4, so it's 10.4 squared. I know the 12 minus y is 6, so plus 6 squared equals c squared. So my 10.4 squared is 108.2 approximately, plus 36 equals c squared. So that's 144.2 equals c squared. I square root it, I get about 12. So we'll call it 12. So that gives me my x and my c. So up here in this big equation number 1, I know x, I know y, I know c, and I know dc dt. The only thing I don't know is dx dt and dy dt. That's also the unknown here in equation 2. So I'll have two equations with two unknowns. So I'm going to rewrite those. I'm going to rewrite equation 2 first. 2x dx dt plus 2y dy dt equals 0. That's the first equation in my system. The second one will be this equation number 1. but I'm going to plug in some of the stuff I know. And I'm going to do that down here. So I've got, need a little bit of room. X we knew was 10.4. dx dt we don't know. Y we knew was 6, so 12 minus y is 6. dy dt we don't know. Then it's 2 times c, which we found c to be 12. So that's 2 times c is 24. And we knew that to be negative 0.2. So I'm going to multiply all that together. 24. All right, c was 12, yep. So 2 times 12, we got a 24 times negative 0.2. That gives us negative 4.8. So now when I bring this down into the system, I am going to do a little more simplification. The 2 times the 10.4 is 20.8. Sorry. 20.8 dx dt. Then I do the 2 times the 6 times the negative 1, so I'm getting minus 12 dy dt equals negative 4.8. This equation, I can plug in my x to get 20.8 as well. My y was 6. So I can get 12 dy dt equals 0. So these are my two equations in my system. So I'm going to then combine those. This lines up nicely, it looks like. Hopefully I didn't do something wrong. This looks almost too nice. When I combine them, I can just add them because this will equal 0. So I'll have 40, so what's that? 8 and 8 is 1.6. So I'll get 41.6 dx dt equals negative 4.8. So now when I solve for dx dt, I'm going to get negative 4.8 divided by 41.6. That's going to be, let me divide this. .115 we'll call it, and that's negative. That's the rate of change of the horizontal distance. Let me check the back and make sure that that's right before I move on. What number was this again? A lot of work. It's all the way up here. 29. So for 29, I've got my horizontal rate of change. The book says the square root of 3 divided by 15. So I'm going to do that out. The square root of 3 divided by 15, and it's negative. And that is the correct answer. So now to get dy dt, we choose either one of these two equations. I like that first one. It looks a little more simple. So I go 20.8 times dx dt, which is negative 0.115, plus 12 dy dt equals 0. So I multiply this stuff, subtract it, and divide by 12. And I'll get dy dt equals 1/5. About 1/5, or approximately 0.2 meters per second. Are we doing here? Yeah. And that was meters per second. And that's what our prediction was about, at least about the signs. dy dt was getting larger, so it was a positive rate. Dx dt was getting, x was getting smaller, so dx dt is a negative rate.